a prism is a shape that has the same cross section all the way through. What I mean by that is this. Suppose we have a prism like this one here. Now, this is a triangular based prism. All right, this is a triangular based prism. And what I'm going to do is to try and translate, slice it through its length. So think of it as a piece of bread, and I'm just trying to slice through its length. What I'll end up with something like that. I'll end up with these slices. And you can notice here that the area of each of these slices is the same. Like this area is the same as that area and the same as that area. And that's what we mean by constant cross section. So this is what we mean by constant cross section. So all through, you can see that this shape has a constant cross section all through its length. All right. And the same applies to, for example, if I have a shape like that, again, we have a constant cross section all through. If I translate it along its length, we have a constant cross section all through. Yeah. And even if I have any, so this one here has a special name. This is a square-based prism. And you can have that, okay? Again, if you slice it all through, you have a constant cross section. So that's what I mean by constant. Even if you have a, hexagonal based prism, again, here we have a constant cross section all through. So what you are saying here is, remember, we are saying that a prism is a shape that has the same cross section all through its length. So we can use that idea to identify here what is a prism and what's not a prism. So that definitely is not a prism. That's a prism. That's a prism. That's not. That's a prism. That's not. That's not. That's a prism. And that's a prism. Now, why is this important? We can use this idea to find the volume of a prism. So the volume of a prism is equals to the area of cross section multiplied by the length. Okay, so if we can be able to find the area of the cross section, all right, if we can find the area of the cross section, then we can just multiply it by the length and we get the volume of the prism. For example, in the next page, I'll show you how to work this out. So the first thing that you need to do is to identify the cross section. So here, this is the cross section, right? This is the cross section again, right? And here, that can be the cross section, that bit at the end. Or actually, it doesn't matter. We can choose this to be our cross section as well. All right, so that is our cross section. That's also our cross section, and that is our cross section. So to find the volume, for example, in A, volume will be the area of the cross section, which is 25 multiplied by 7, and that will give us 175 centimeter squared. In B as well, volume will be 26 multiplied by 12, which gives us 312 centimeter. This is volume, centimeter cubed. So centimeter cubed. And then for the last one again, see, volume will be, now we have to find the area of the cross section. The cross section here is 10 multiplied by 5. So our volume will be 10 multiplied by 5, right? And we multiply that answer by 3. Okay, multiply that answer by 3. So we end up with 150 centimeter cube. So very important, identify the cross section and then use the formulas to find the volume of the required shape. Again, here I'll start by identifying the cross section. So this is my cross section. That's my cross section, right? So starting with the first one here. So the volume will be the area of the cross section. Now the area of the cross section is 6 multiplied by 3 divided by 2. And then I multiply that by the length, which is 10. And what I'll end up with is, so that will be 9 multiplied by 10, which is 90 centimeter cube. For B, again, if you look at this bit, the cross section, so volume will be area of cross section. Just go back. So volume will be equal to the area of cross section, which is pi multiplied by 12 multiplied by 12 multiplied by the length, which is 20. All right. And again, if you notice, what I'm trying to do is, this is the cross section here. All right. That's the cross section. This one here is the cross section as well. So you start by working out the cross section, multiply that by the length, and then you get the volume. All right. So let's carry on. So this will be equal to 9047.8 centimeter cube. Next question. Find the volume of the following prisms. Again, it's the same process. Start by identifying the cross section. And again, this is my cross section here. And here, that will be my cross section as well. So identify the cross section, and then you can carry on and find the volume. All right. So let me start with A. So the cross section here will be a trapezium. So volume will be, to find the area of a trapezium, it's a half into A plus B. Remember, this is 2. So 5 plus 2 multiplied by the height, which is 3. And what I'm going to do is I'll multiply that by 4. So this bit here is my cross section. All right. So this is my cross section. All right. So if you work out that, you should be able to end up with just 42 meters cubed. All right. The next bit, again, I'll work out the cross section. So here, what I have is, I have A and B. You know, my cross section has 2 bits, A and B. So area of cross section here, area of cross section. It will be equal to area of A plus area of B. Now the area of A is 6 multiplied by 4. And the area of B will be equal to, it's a half a circle, so that will just be pi multiplied by 2 multiplied by 2 divided by 2, because it's a half a circle. So that will be 24 plus 6.3 which gives me 30.3 centimeter squared. All right. So this is all, this is the cross section, right? So all this bit here, all this bit is calculated here. That's a cross section. All right, so I can carry on and find the volume. So the volume will be area of cross section, which is 30.3, multiplied by the length, which is 15.3. And that will give me 463.6 centimeter cube.